Welcome to Module 4 of Programming Logic using Python. In this micro lecture, I want to discuss decision structures. Now, normally when I discuss decision structures, there are two main structures that I want to talk about. The first structure that I want to talk about is called an if statement. An if statement is a statement where we can ask the computer to make a decision on what we want to happen. Normally, our if statement has inside of it the if and then the Boolean expression that we want the computer to determine whether it is true or false. And if it determines that it is true or false, it will run the statements inside the branch of the if. And if those statements are false, it'll fall through the if statement to the next branch if there's an else if or an else, or if there's just an if, it'll fall all the way through. Okay, great. The other specific thing that I go over in great detail are switch statements. Switch statements are not found in Python. They're not an object. I'm sorry. They're not a structure that exists for us to use. Python only uses if statements at this point in time. But in Java, C#, C++, and I believe C, JavaScript, Perl, and PowerShell, they all use switch statements as well. Now, what's a switch statement? A switch statement is a statement that allows us to evaluate an expression that we've been provided. So in this case, I would put a variable here, and then I would check to see if that variable contains or is assigned the value that's in the case. Now, in the case, like that pun, in the case of a switch, it is unlike an if statement, whereas a switch statement will only execute one of the cases and never execute any of the other cases afterwards. It'll skip it, right? And what a switch statement doesn't do, which if statements do, is a switch statement does not evaluate each case from top to bottom. If statements do evaluate each case. So in this case, if I come here, you can see if the code, right. So if I is greater than 15, then do this. If this is false, it'll evaluate the next thing in line. Down and down and down and down and down. So if I come down here to the next if else, if this determines to be false, then it'll run the else. But it has to determine that first, right? It has to determine if this is false or true first before it can go to the next branch. Well, that's not true for switches. In switches, it will jump to the case that's true and evaluate that, and then leave. It will leave when you tell it to break. Now, break is a very interesting statement because break is a jump statement we use in for loops. So in my mind, I think to myself that a switch is a for loop that's checking the cases against the expression that's provided, and then when it finds it, it breaks. This is the beauty of switches. And in a roundabout way, switches are nominally more efficient than if statements because there's not a lot of evaluation going on. It knows where to go immediately and it goes there. One last thing about switches, and then we'll get back to the Python version of things using ifs. A switch, in and of itself, does contain the default. And what your default does is if all the cases are false, so let's say this expression is a variable that contains the letter Z, okay? Case X is not true, case Y is not true, so it would actually default, and you can think of your default case as your case which is the same as the else branch in an if statement. All right, enough about switches. And let's get back to REPL. So let's get rid of all of this. And let's create a decision structure. So I want to do something. I want to check to see if a user is giving me a input that I want. So first things first, we're going to say input response equals, response being the variable that is assigned the value of input, which is going to be a string, and then I say, please enter a number between 1 and 10. Fantastic. Now, if I wanted to check to see if that is going to give me what I want, I can say check response, so print response will print over here, right? And instead of using the debugger, I just want it to run. So I'll say run, and you can see it down here. it should give me the question or the request. Please enter a number between 1 and 10. I will enter the number 10. And it printed the number 10 because that's what's saved to response. So this is working correctly. Great. Let's go ahead and write our if statement. So there's a couple of things I want you guys to think about. I want you to think in terms of edge cases and unhappy paths. Think to yourself, pause the video after I ask you this question, please. What do you not want to happen? And go ahead and write that down. There should be about 3 things we don't want to happen. There are 3 things we don't want the user to try to give us. It's already defined in the string that we wrote there. Please enter a number between 1 and 10. So now look at your keyboard and ask yourself, what can a user press that I don't want them to press? And I do not want to have to determine that they pressed. Well, the first thing I don't want is I don't want symbols and I don't want alphabets. All right, I just want digits. So if I just want digits, there's a function in Python called isNumeric. isNumeric does a isNumeric performs a check on a string to see if that string can be converted or cast as an integer or a float. In this case, that is exactly what we're about to do. Because if we tried to cast or convert the value that we're receiving from the input of the user to an integer and it can't be converted, this is what happens. So let's do this. Let's say response or input equals response equals response, spell that right, equals, I'm going to use the same variable twice, by the way. So response equals int response, right? If I want to check to see if this is an integer, then I need to convert this string, because response is a string at this moment in time, because the input gives us a string, right? So response is a string. You can see that right there, str, right? Since response is a string, in order for me to validate if the number is between 1 and 10, what I need to do is I need to convert that to an integer. So that's exactly what I'm going to do here. Well, when I convert this to an integer, let's find out what happens. If I tried to convert the letter A to an integer, what happens? Hey, you're not allowed to do that. Look at that nasty error there. Invalid literal for int with base 10. Imagine if you sent that to the end user. Imagine if they got that error. It would probably be in all red too. They would be very nonplussed by that, and they would not want to use your program again because that error is not elegant. So in the event that the user gives us a response we don't want, in this case a alphabet or a symbol, we can use the isNumeric function to find out if they're giving us the right thing. So before I do any casting, in this case I'm casting the response string to an int so I can check to see if it's between 1 and 10. Well, what I want to do first is if not input, or yes, if it is not numeric, right, then I want you to say print response. We're going to do a string concatenation here. Response is not numeric, is not a number. Please try again. So now when I run this, what should happen is I should get the prompt again. All right, we're going to use the same value. We're going to say A. What happens? I get the error again. Built-in function or method object has no attribute isNumeric. Oh, why not? Oh, because input doesn't exist. It's response. My apologies. Run that again. Input's not a variable. I didn't create input, so it's telling me that input was not created. I want to pause here. If you're not developing alongside me right now, you are wrong. I would advise you very strongly to open up your REPL.IT and or Visual Studio Code and start typing this code in so it can start becoming a part of your frontal cortex, and then try as you might on your own to commit this to your long-term memory storage in your hippocampus, you won't. So the more you type it, the more it will stick. Do not let AI grab a hold of you. Turn that off. How do you turn AI off? Oh, that's very easy. At the bottom of your REPLs, at the bottom of your program file, click on AI. Turn off enable. Notice I'm not getting any AI. Now, I'm not telling you to turn off AI because I don't want you to cheat. By all means, use it. The problem you're going to run into is AI is going to start telling you things that you don't want to do. As a newbie to Python, as a beginner, as a junior dev right now, I would advise very strongly that you turn that mess off and you fight through the problem. You fight through the problem. Don't let AI tell you what it wants you to do. You deny it until you get your arms wrapped around this, and then I would say you can turn it back on. Okay, back to our regularly scheduled program. I'm typing in the letter A, and look at that. I didn't get this nasty error. What did I get? Hey, A is not a number. Please try again. That's great. That's an unhappy path that I don't want. There is one more unhappy path we're going to code for. That unhappy path is if the number is not between 1 and 10. Okay? So if I wanted to just catch everything else, I would say else, right? And then I could say in the else statement, if int response is greater than 10 or int response is less than 1, then print response plus the string I want, so plus is out of bounds. Please try again. And this will work, right? We call this a nested if. This is a nested if, right? That's not spelled correctly. Response. There we go. This is called a nested if. There's an if statement and an if statement, and this will work. So if I press run, and let's do it from the top to the bottom again. Let's do A one more time, or we'll do a symbol this time to show you that it's not just letters. You can also catch symbols with is numeric. Exclamation point or bang sign is not a number. Please try again. Good. Now let's try an alphabet. These are the 3 use cases I don't want. The first one is symbols. The second one's an alphabet or a letter, B. Enter. B is not a number. Please try again. Great. It was the right use case. Let's run this. Now let's try a number that's not between 1 and 10. 15. 15 is out of bounds. Please try again. This worked. So what are we doing here? Well, in this if statement, we wrote 2 Boolean expressions because we want to do 2 conditions. And we use the or in between to check if this or that is true, right? If this or that is true. If either one of these is true, so let's say this first one is true and the second one is false, then the whole expression is true, and this will fire. If the second condition is true and the first condition is false, this is true and the whole thing will fire. If I wanted both of them to be true, then I wouldn't use the word or. I would use the word and. Now in this case, and's not true because 15 cannot be greater than 10 and less than 1. That's not possible. So I don't want and. I just want or. Let's refactor for a second here though. Is this nested loop, or I'm not loop, is this nested if statement necessary? Do I need to do this? Well, no, I don't. Actually, I can just say elif. And this will capture the same thing. And what will happen is the if statement will fire first, and then the elif will fire second if the if statement is not true. In this case, we're going to debug. So let's start our debug at line 5. Once we get to line 5, we will walk through the answer. So in this case, I'm going to give it another symbol. So we're going to say $, right? Please enter a number between 1 and 10. $. Is a symbol. It's not a number. So guess what's going to happen? It's going to fall into the first if statement. And this first if statement is taking that $, via the variable response, and it's checking to see if it's not numeric. And what's going to happen, as you can see here, is the function is numeric is going to return a Boolean value of true or false. That's what we want. Well, in this case, it returns true. But what's true? Well, it is true that response is not numeric. That's what's true. So if that is true, then I want you to print this, this output. And so it does. And there you go. Dollar sign is not a number. Please try again. If we did this again using a letter, so this time we'll do, when it decides to load up, we will put in here capital E. Here we go. Response is now capital E. As you can see there, it's capital E. Great. I'll make it a little bigger so you guys can see it better. There we go. All right, it's capital E, which is still not a number. So we're going to, this is true. So now it's going to fire, and it's going to say, hey, bud, E is not a number. Please try again. Great. Well, now let's check to see if this next else if is working right, and let's see what actually happens, right? So we're going to run it. We're then going to put in a number that does not exist between 1 and 10. So we're going to put in 25. And the answer is it numeric? Is 25 numeric? Can I cast that as an integer? Well, the answer is absolutely, which means that this is false. It is numeric. It is not numeric. That's a double negative. Never say that again. Therefore, this if statement is not true. So it's going to go to the next branch in the statement, which is the else if. And now it's going to ask itself a series of questions. Is it greater than 10? Well, yes, it is greater than 10. Is it less than 1? Well, no, it isn't less than 1. So is this true? If you said yes, you're absolutely correct. It is true. And line 8 will now fire, and we will get 25 is out of bounds. Please try again. But this is not the end. We have only developed for the things we don't want to happen. We have only developed for the unhappy paths. We now need to develop for the happy path. And the happy path will end up in our else. Our else will say, print response, the number is response. And if I run this, and I put a number in there that was right, so in this case, I'm going to put the number 5. Is the number 5 numeric? Yes, it is, so we'll skip over that. Is it between 1 and 10? Yes, it is. So both of these expressions are false. Skip over that. Guess what just happened? It jumped down into your else statement. And what runs? The number is 5. All is right in the world, right? Wrong. All is not right in the world. We would never write it this way in the real world, at all, period. So now what I'm about to show you is how I would have written this if I was writing this as a industry leading engineer in the real world. So in the real world, we wouldn't write this out there like that, because in certain situations, we would want to run this over and over and over again in like a loop or something like that. So what I really want to do is I want to take all of this code right here, and I want to put that into a function. So let me make a function called def check input. That's the function name. Def means define, and check input is the name. I'm just naming it check input. I want to check the input against what I want to happen. Now what I need to do is I need to determine whether or not I need a parameter passed in. Well, I do need a parameter passed in because I'm not going to put this inside of the function. So I will name this input. I want to pass in something, so I'm going to give it something that I want it to be. Now what I'm going to do is I'm going to take this if branch, I'm going to stick it into that specific function, delete this, and make some spaces so you can see what I'm doing. I'm not going to do a whole lot to this if statement, but what I am going to do is, because I created these unhappy paths, I'm going to force these unhappy paths to turn into exit conditions. So if this is true, okay, I don't want anything else to fire. I want to leave the function. Don't evaluate anything else. Now, this is an efficiency concern. We want to be efficient about the way we develop, about the way we engineer our code. There are certain reasons for that. Reason number one is there are certain devices, okay, there's certain devices that can't handle a lot of processing power. So we need to be thoughtful and mindful of how we ask those devices to do certain things. So instead of doing an if branch that is very top down, what I'm actually going to do is a series of ifs. I'm then going to ask myself another question. Do I need to print? Well, no, I don't. All I need to do is respond I want to respond with the value that I want to print when I'm going to print it. So just follow along with me for a second here. What I'm going to do is I'm going to use the jump statement return. Now what return does is return returns to the line that the function was executed, and it delivers the value that has been returned. So when a function, and we haven't spoke about functions yet, so I'm getting you familiar now. When a function does not return a value, we call that a void function. This is not going to be a void function. This function will return a value. So in the case that I want to return a value, I have to use the word return. I am also going to change this up a bit, and I want to use a string interpolation to define what I'm doing here. So what did I do here? Well, I said I want to return the string this, right? What is this? It's the same string we've been returning the whole time through our print function. Notice that this print function still says response plus and that. Well, I like using string interpolation because this is more readable than this. This is not very readable. This is called string concatenation. It's very efficient. You can use it if you want to. I'm not saying don't. But string interpolation is far more efficient to read. And reading is half the battle. G.I. Joe, right? Well, knowing is half the battle. But either way, this in and of itself is how I like to write my strings when I'm returning a value. Input is the input that the user has sent in. I just haven't coded that part yet, right? The user is going to send me an input. So I called it input. The variable name is input. The parameter name is input. And I'm going to show you how I use this later. Either way, if this is not numeric, I don't want you to run anything else in this function. I want you to leave. And that's what return says. Leave. All right? What happens here? Like, what would I do here? The same thing. Now, I want you to notice that I don't have if, else, if. Because I don't want these connected at all. I want this to be its own exit condition relative to this being its own exit condition. Now, in this case, I will do string interpolation again. String interpolation requires you to use one quotation, and then curly brace, and curly brace. And there we go. Well, these are my happy paths. If I try to run this, it'll probably tell me that not all paths lead to the end, because these are in if statements, and they could be false. They both could be false, right? So what do I really want to happen? Well, I want a final return here for my happy path. Same thing. Same thing. My suggestion is, whenever you write your code, write it the most efficient way you know how to write it the first time. The most easiest way. It doesn't have to be efficient. And then do what I'm doing right now. Refactor. The more you refactor, the more your first draft will look more like your final draft. This was not my first draft. My first draft was a if branch that was below this input that printed a bunch of things. Now my second draft, like I'm writing a paper, right? My second draft is refactored. Now what's going to happen? Well, nothing really, because I didn't tell anything to do anything, right? All I did was write a function. Well, what's a function? A function is a collection of programming statements. That's what it is. I haven't executed it yet. So if I put anything in here, it doesn't matter, nothing happens. Why? Because there's no print statement down here. I didn't tell it to execute this function. Well, how do you tell it to execute that function, Professor Fiske? Well, kind of like this. Output equals check inputs response. And then I would print output. Now what will happen? Well, let's do the happy path. All right. The number is 5. Oh, it looks like it worked. One more thing. I actually wouldn't do this. I wouldn't save it to a variable and then print it. This is like overkill. You don't have to do this. You can actually take check input, place it in there, and it'll work the same because you're returning a string. So if I did 5 again, do the same test again. Great. I know this was a long lecture, but there's one more thing I want to do. I want to debug this with you through all 3 cases. All 3 use cases. Let's do the unhappy path first, and then we'll do the happy path. So let's print, or let's debug. Let's put in a symbol. @ So look at this. All right, it stopped here. If not, response is numeric. It literally stopped. Oops. That's where I want it. So if not numeric, this is a numeric. So it went to the right spot. I didn't show you what happened though. My apologies, I got excited. So here we go. I'll do that again, @. Or that's fine, £, pound key. Here we go. Is that numeric? No. So this is true. So what's going to happen? Well, it's going to leave. And the response is now that string that we just create. The check input's going to return. So if I go to check input and I push this down, special variables, and I should be able to look at built-ins, I think is what it is. Where is it? I always have a hard time finding this on REPL.it. I want to show you the return. I'm running out of time. This has already gone too far. Or too long, I should say. But either way, special functions, special variables built in. Either way, long story short, this is going to print that statement that we just produced. So if I said finish, that's not a number. So let's go to unhappy path number 2, which is it a letter? Q. Notice, is it numeric? No, it's not. So what's going to happen? Well, that's true. So it's going to return that string. And now what happens? Q is not a number. Please try again. Great. Let's use unhappy path number 3, which is it's out of bounds for that specific 1 through 10 set. I'm going to try a negative number. I've done this before and it didn't work, but I want to see if it works this time. So is it numeric? Yes, it is. So let's just skip over that. It said it wasn't. This has happened to me before, so I still haven't figured. I haven't cracked the case on that one yet. But let's debug and let's use a number that we know is going to work. 0. 0 will work. So is 0 numeric? Yes, it is. So that's not true. Is 0 between 1 and 10? No, it is not. So it's going to jump into this specific if statement. And then it's going to print 0 is out of bounds. Please try again. That was our third unhappy path. So now let's do our happy path. What's our happy path? Well, it is the number between 1 and 10. So for all intents and purposes, let's use 10. What happens? Well, is it numeric? Of course it is. So that's false. Is it greater than 10? No. So that's true. Is it less than 1? No. So that's false. But because the first expression is true, and the second expression or the condition is false, and this is an or, either or has to be true for this whole expression to be true, so it should not work. Because it's not greater than 10, and it's not less than 1. Sorry, I said that incorrectly. I got excited. This is the happy path, and it worked. So now the number is that, and the answer is this. And that's it. Well, I want to stop here. If you have enjoyed these lectures, please like and subscribe. They do wonders to let me know whether or not they're content you care about and want to know more about. Otherwise, as I say in all my videos, good luck, have fun, ciao.